Okay, so for this video, we're going to be talking about data visualization and the issue of presenting misleading figures of data. So data visualization is a key part of how we share our research findings. And as we decide how to visualize our data, we need to be mindful of how readers might interpret our data figures. So let's take a fairly standard design for researching the effects of instruction on second language learning. We could imagine a study where one group of learners received an experimental type of teaching and the other group received a traditional type of teaching. So the effects of these two teaching approaches would be measured by examining learners' changes in their test performance before and after the intervention. In other words, doing a pre-test and a post-test. So upon analysis, the results from this study showed that the experimental group's average scores increased from 74% on the pretest to 77% on the post-test, while the comparison group's average scores went from 74% to 75%. So one way we could present these findings is using a line graph with time on the x-axis, i.e. the pre and post, and then average score percentage on the y-axis. So for percentage data, we might expect the y-axis to range from 0 to 100. However, this might make it harder to see those changes between the pre and post-test scores, or we may feel that this doesn't highlight the differences that we want our audience to note between the two groups. So we might be tempted to present a graph with the y-axis ranging from, say, 70 to 80% instead of 0 to 100. And this makes the difference between the pre and post-test scores for the two groups really noticeable. But by zooming in like this, we are removing important context, namely that the two groups only improved by 3% and 1% out of 100%, and not just out of that 10% range that we're showing. So while our y-axis may be labeled accurately, like it may be labeled that we're going from 70% to 80%, a casual reader might glance at a graph, looking at this, see it's only 10% of the possible data range, and looking through quickly get the impression that our findings were more substantial than they actually were. In other words, this could be misleading our readers on sort of the impact of the treatment that we tried out in our study. So as we prepare our figures, it's helpful to ask ourselves how a reader might reasonably interpret the data figure and whether misinterpretation is likely.